Welcome back to the deep dive. Today, we are doing something a little different.
Yeah, a little more inward looking.
Exactly. Usually we look outward, we're analyzing tech trends, we're digging into history or, trying to make sense of the economy. But today, we're turning that lens around 180 degrees,
We're looking in the mirror.
quite literally and figuratively. We're talking about us, the human story. We've got a massive stack of research today, but it's all centered primarily around this one book, Human, the Definitive Visual Guide from DK.
And that word definitive is, it's doing a lot of heavy lifting. It's an absolute beast of a book.
It really is. I mean, it covers everything from the microscopic architecture of your cells.
All the way up to those sprawling mega cities that we've built.
It's the whole story in one volume. And honestly, it's a story that is so much weirder and I think much more improbable than most of us realize when we're just, getting our morning coffee.
I think that's the perfect way to put it. Improbable.
And the source material kicks off with this one idea that I think just frames the entire discussion perfectly, the mirror test.
Right. The classic scientific test for self-awareness.
Yeah, for anyone who hasn't gone down this particular rabbit hole, let's just unpack it for a second. It's a study where researchers will put a little mark, like a dab of red paint or something.
Usually on the forehead, somewhere they can't see it directly.
Right. And then they put the animal in front of a mirror.
Mm-hmm.
And the whole question is, what do they do? Do they try to wipe it off? Do they realize, hey, that's me in there?
And the results are just incredibly humbling when you look at them. I mean, most animals, they just see another animal.
They attack it.
Or they try to play with it, or they just get bored and ignore it completely. It's only the absolute, the valedictorians of the animal kingdom,
Okay.
chimpanzees, gorillas, dolphins, maybe some birds like magpies, that show even a flicker of recognition.
It's just a flicker.
They'll look at the reflection, and then they'll touch the spot on their own face. They get it.
But for us, I mean, it's instantaneous, isn't it? We don't just see a reflection. We obsess over it.
Oh, complete.
We're fixing our hair. We're checking if there's food in our teeth. We're analyzing how we're aging.
And that's the hook, really. We have this profound, and sometimes, let's be honest, overwhelming self-awareness. We're the only species on the planet that lies awake at night wondering what we are.
And that drives this central paradox that the entire deep dive is about.
Which is?
Well, you tell me.
It's that biologically we are just another animal. I mean, we're a mammal, we're a primate, but experientially, in our own minds, we feel completely separate from all of that.
The source makes this point right at the beginning. We share, 98 to 99% of our DNA with chimpanzees.
It's an almost negligible difference. If you could strip away the smartphone and the sneakers and the anxieties about your mortgage.
Right.
We are biologically almost identical to them.
99%. That is such a small margin. It's basically a rounding error in the grand scheme of things.
It is. But that 1% difference, well, that's the difference between sleeping in a nest made of leaves.
And walking on the moon.
Exactly.
That's the image that really stuck with me from the introduction of the source. July 1969. Humans walking on the lunar surface. How does a species that is, and this is a quote, a mere twig on the animal family tree, how do we manage to leave the planet?
And that is the mission for today, isn't it? We're going to try and bridge that gap. We're going to trace the line from the microscopic blueprint inside every one of us to the physical machine of our bodies through the messy, winding road of our evolution, all the way to the civilizations we've built.
From stardust to skyscrapers.
Essentially, yes. It's a big story.
Okay, so let's start at the absolute bottom, the micro level, the blueprint. Because when I look down at my hand, I just see skin, maybe a freckle or a scar. But the source breaks down the sheer scale of what me is and the numbers are. Well, they're honestly hard to process.
They are staggering. You are not a single organism, really. You're a walking, talking colony of about 75 trillion cells.
75 trillion. That number is so huge it just loses all meaning.
Okay, think of it this way. You aren't a single thing. You are a city, a living, breathing metropolis. And these cells, they aren't just bricks, dumbly stacked on top of each other. They're social.
That was a distinction that I thought was really cool. They talk to each other.
Constantly. They're basically sending chemical text messages back and forth all day, every day. Hey, we need more oxygen over here. Watch out, there's an intruder at the northern wall. Contract this muscle fiber now.
And they're all specialized. You've got your nerve cells, your muscle cells, blood cells, all doing these radically different jobs. But, and this is the mind-blowing part, They all came from one single fertilized cell.
The complete instructions for the entire city were in that first brick.
It's unbelievable.
And it gets even more complex when you zoom in on one of those cells. Inside, you have organelles. You can think of these as the organs of the cell itself.
Right, and the source made a point of highlighting the mitochondria specifically.
The powerhouse of the cell.
I feel like that phrase, mitochondria is the powerhouse of the cell, is the one thing everyone, and I mean everyone, remembers from high school biology.
It's become a generational meme, hasn't it?
It really has.
But what the textbooks often just gloss over, and what this guide really highlights, is where they actually come from. Yes, they generate the energy. They take the glucose from your food and turn it into the fuel that runs everything. But they have their own DNA.
Separate from the main DNA that's in the nucleus.
Completely separate. A little loop of their own genetic code. And here's the kicker.
Okay.
You only inherit it from your mother.
Wait, really? So my dad's mitochondria...
They're a dead end. They didn't make the cut. The sperm's mitochondria are basically jettisoned during fertilization. So every single person listening to this right now has mitochondrial DNA that traces back through a pure, unbroken maternal line.
So my mother, her mother's mother.
All the way back. It's a biological thread that connects you directly to the women of history. Scientists have used it to trace human migration patterns back to a single mitochondrial Eve in Africa.
That is incredible. It's like a secret history that's written in our cells.
It really is.
But speaking of history and instructions, we have to talk about the main event inside the cell, the nucleus, the library.
The control center. This is where the main event, the DNA, lives. The famous double helix.
The twisted ladder.
Right. We've all seen the picture. But functionally, I think it's better to think of DNA as a recipe book.
But not for a cake.
Not for a cake, no. It's a recipe book for making proteins.
And proteins are the actual building blocks, right?
They're the workers. They're the bricks and the mortar and the electricians. They build the structures. They run the chemical reactions. Your DNA determines if you have blue eyes or brown eyes, sure, but that's just a protein pigment. It also determines how your liver processes toxins or how your muscles rebuild after you go to the gym. It's all about proteins.
And the replication process, the way it copies itself is just, it's so elegant.
The unzipping. It's beautiful. When a cell needs to divide and create a new one, that DNA ladder just splits right down the middle like a zipper. Each side then acts as a perfect template to build a new matching half.
So you end up with two perfect copies from one original.
It's an ingenious system for preserving information across trillions of cell divisions. And all of this information, this incredibly long string of code, is bundled up into packages called chromosomes.
46 of them.
23 pairs, to be exact. You get one set of 23 from your mom and one set from your dad. That's the lottery of existence right there. You get a random shuffle of their genetic cards, and that's what makes you, you.
Okay, so we've got the bricks, the cells, we've got the blueprints, the DNA. But a pile of bricks in a book of blueprints doesn't make a house. We need structure.
We need systems. And that's the next level up. The cells group together to form tissues. You have epithelial tissue, which is your skin. You have connective tissue, muscle tissue, nerve tissue.
And those tissues form organs, the heart, the stomach, the lungs.
And then finally, those organs work together in systems. The digestive system, the respiratory system, the circulatory system.
And the big takeaway from the source here, the point it kept hammering home, was interdependence.
Yes, absolutely vital interdependence. Nothing works alone.
You can't just look at the heart in isolation.
Not at all. The heart is an amazing pump, but it's useless if the blood it's pumping doesn't have any oxygen in it. For that, you need the lungs. But the lungs can't move without the muscles of the diaphragm,
which are powered by nutrients from the digestive system,
which is controlled by signals from the nervous system. It's this incredible, intricate web. If you cut off the blood supply to a tissue, the tissue dies. If one system fails, the whole machine starts to go dark.
It's like a house of cards, but a really, really sturdy one.
A very resilient house of cards, yes.
Yeah.
Built over millions of years.
So that's the microscopic stuff. Let's zoom out. Let's look at the actual physical machine, because one of the biggest things that sets us apart from our primate cousins, maybe the biggest thing, is just how we get around.
The upright revolution.
Bipedalism.
We are the only mammals that stand, walk, and run on two legs as our primary mode of transport. I mean, kangaroos hop, but...
Right, and ostriches run, but for mammals, we are the weirdos. And the source makes it so clear. This wasn't just a simple matter of deciding to stand up one day. It required a complete, and I mean complete, remodel of the entire skeleton.
A painful remodel, it sounds like.
In many ways, yes. If you look at the spine of a four-legged animal, a dog or a chimp, it's like a bridge. It's a simple arch. It's great for hanging organs off of. But if you try to stand a bridge on its end, it's going to collapse.
So we developed the S-curve? Exactly. Our spine is shaped like an S. It acts as a spring, a shock absorber. Every single time you take a step, that curve compresses and decompresses. If your spine was a straight rod, the shock would travel right up to your brain. Your head would literally rattle off your shoulders every time you went for a jog.
So, is that why my lower back hurts all the time?
Almost certainly. It's a brilliant piece of engineering, but it's also a compromise. We put a huge amount of pressure on that lower curve, the lumbar region. It's a structurally vulnerable point that we pay for in exchange for the freedom of walking upright.
And there's the pelvis. That had to change too.
The pelvis is crucial. In apes, it's long and narrow. In humans, it had to become short and bowl-shaped. There are two big reasons for that.
Okay.
One, it needed to literally be a bowl to hold your guts in because gravity is now pulling them straight down instead of letting them hang.
That makes sense.
And two, and this is the big one, it had to change to provide a proper anchor point, a leverage point, for what might be the single most important muscle in human history.
Please don't say the brain.
The gluteus maximus, your butt.
The butt is the key to humanity. I love this.
It really is. I'm not kidding. Apes have these flat, unimpressive butts. Humans have large, powerful, muscular glutes. They're the engine that pulls our leg back with each stride and, critically, keeps our torso upright and stable. You literally cannot walk like a human without them.
I'm never going to look at walking the same way again.
You shouldn't. And it doesn't stop there. Your femur, your thigh bone, it does something weird too, right?
Carrying angle.
Yes, the carrying angle. If you stand a chimp on two legs, its knees are really wide apart. It has to waddle from side to side to shift its weight and keep its balance. It's very inefficient.
I've seen videos of that. It looks awkward.
It's very awkward. But our thigh bones don't go straight down. They slope inward from the hip. This brings our knees directly under our center of gravity. That's what allows you to stand on one leg effortlessly while the other one swings forward. It lets us glide.
But, and there is always a but in evolution, isn't there? This whole remodel, this new pelvis, came with a massive, massive cost. The source calls it the evolutionary compromise.
The obstetric dilemma. This is the dark side of bipedalism. It's a brutal trade-off. To walk upright efficiently, you need a narrow pelvis. But at the very same time in our evolution that our pelvis was shrinking, our brains were getting massive.
Big head, small exit.
That is the problem in a nutshell. In almost every other mammal, birth is relatively straightforward. A foal can stand and even run minutes after being born. But for humans, childbirth is exceptionally difficult, painful, and for most of our history, incredibly dangerous. The baby's head can barely fit through the mother's pelvic outlet.
And because of that, our babies are born. Well, they're basically born premature compared to other animals.
They have to be. If a human baby stayed in the womb until its brain was as developed as, say, a baby chimp's, it would never get out. So we are born utterly helpless. A human baby can't even hold its own head up for months. It's a little floppy, needy thing.
Which, and this is the cool connection the source makes, forces us to be social.
Yes. It's a biological imperative. You cannot raise a human baby alone in the wild. It's a full-time job for years. You need a partner, you need a tribe, you need a grandmother to help. The sheer biological difficulty of our birth forced us to invent childcare, which laid the essential groundwork for society itself.
So learning to walk upright literally made us nicer people, or at least more cooperative people.
It forced us to rely on each other. It's a perfect example of how biology drives behavior.
Let's talk about the other end of the body for a second. The hands. The moment we stood up, our hands were free.
Free to change the world, and they changed too. We developed what's called the precision grip.
As opposed to the power grip.
Exactly. An ape has an incredible power grip. They can hang from a branch by one arm all day. They can crush things. But try asking a chimpanzee to thread a needle or hold a pencil or chip away at a piece of flint to make a tool.
They can't do it. Their thumbs aren't fully opposable like ours.
We can do both. We have the power grip to hold a hammer and the precision grip to use a paintbrush. That dexterity is what allowed for the entire history of technology to unfold.
But there's another physical trait I really want to hit on because it's one of the strangest things about us when you stop and think about it. We are the naked ape.
Yes, it's so odd.
You look around the rest of the mammal kingdom, everyone else is wearing a fur coat.
Yeah.
Gorillas, bears, wolves, we're just skin. Why?
It all comes down to temperature control. We evolved on the open, scorching, hot plains of the African savanna.
So we needed a better radiator.
We needed a way to dump heat while we were on the move, especially while hunting. The solution was sweat. We have millions of eccrine sweat glands, far, far more than any other primate. Our whole body is a radiator.
Most other animals pant, right? Like a dog.
They pant, or they have to find water, or they have to stop and hide in the shade during the hottest part of the day. But humans, we can sweat and just keep moving. This allowed for a hunting strategy called persistence hunting.
I find this fascinating.
It's incredible. We are not faster than a gazelle, not even close. But we can outlast it. We can just jog and jog and jog for hours in the midday sun, sweating the whole time until the prey literally collapses from heat stroke.
We are the Terminators of the savannah. We
Actually,
just keep coming.
It's a terrifying superpower when you think about it from the prey's perspective. And that naked skin, it needed protection from that same sun, which is, of course, where skin color comes in.
Melanin.
Right. Dark skin was the original human adaptation, a powerful natural sunscreen against the intense African UV radiation. It prevents sunburn and skin cancer. But as humans migrated north, out of Africa into Europe and Asia, the sun was much weaker.
And you actually need some UV radiation.
You do. Your body needs it to synthesize vitamin D, which is crucial for bone health. So in those northern latitudes, having very dark skin became a disadvantage. It blocked too much UV. So skin became lighter to let just enough in.
It's just a slider bar for geography.
That's all it is. It has no deeper biological meaning than what latitude your ancestors lived at.
One last physical trait before we move on to our history. The eyes. Specifically, the whites of the eyes.
The sclera. This is such a subtle thing, but it changes everything about how we communicate. If you look at an ape, their eyes are mostly dark. The sclera isn't really visible. You can't easily tell where they're looking.
Which is good for a poker game, I guess. Or for hiding from enemies.
It's camouflage for your intentions. But humans evolved this bright white background with a dark iris and pupil in the middle. I can tell exactly where you're looking from across the room just by glancing at your eyes.
So if there's a predator over your shoulder and I look at it, you see me looking at it, and you know to look there too. Without a word.
Joint attention. It allows for silent, sophisticated cooperation. We can signal our focus. Look at this tool, look at that berry bush, look at that lion. It's another one of those small biological tweaks that pushes us relentlessly toward being social.
Okay, so we have the machine. We have the cells, the bones, the sweat glands, the eyes. Now let's put it all in motion. Let's talk about the journey, the origin story.
The 6 million year saga.
The source starts the clock around 5 or 6 million years ago. That's the point where our lineage splits from the one that led to modern chimpanzees.
Right. And we need to destroy a very popular image right here at the start. You know that March of Progress picture?
Oh yeah, the t-shirt graphic. The ape on the far left, then a hunched over guy, then a slightly less hunched guy, and then the cool modern human with the spear on the right.
That one, it's completely wrong. It's dangerously misleading.
Why?
Because it implies that evolution is a straight line, a ladder of progress. We stopped being monkeys and we started being humans. But that's not how it worked at all. Evolution was actually a bush.
A bush.
A messy, chaotic, sprawling bush with many, many branches. For most of our history, we weren't alone. There were multiple different types of hominids, our human-like ancestors living at the same time, often in the same places. We are just the sole, lonely survivors of a once diverse family.
Let's meet some of these ancestors. We have to start with the celebrity. Lucy.
Australopithecus afarensis. She's the rock star of paleoanthropology, lived over 3 million years ago, and she is the smoking gun for that bipedalism first theory we were just talking about.
Because for a long time, the thinking was that we got smart first, we grew these big brains, and then we stood up to use them.
Right. The brain first theory. Lucy and her kind completely destroyed that idea. Her skeleton shows she was fully adapted to walking upright. We have her new joints, her pelvis, and we also have the incredible Laetoli footprints.
Oh, the ones in volcanic ash?
Yes, preserved for 3.65 million years. It's a snapshot of 2 or 3 of them walking together. It's haunting. But the point is, she walked like us, but her brain was the size of a chimpanzee's.
So we were walking tall long before we were thinking deep thoughts.
Millions of years before. The body changed long before the mind caught up.
Okay, so after the Australopithecines, we get the first members of our own genus, Homo. We get Homo habilis, the handyman.
Right. They show up around 2.4 million years ago, and they're the first to be associated with consistent, systematic tool use. Simple stone choppers, but it's a start. It's the beginning of technology.
And then comes Homo erectus.
Upright man. And these are the real pioneers. They were taller, more athletic, with much more human-like body proportions. They had bigger brains than habilis. They're almost certainly the ones who first harnessed fire, and critically, they're the ones who first left Africa.
They spread out across Asia and Europe.
They were the first truly global human species. But the group I really want to dig into, because the source spends a lot of time on them and they're just so compelling, is the Neanderthals.
Our most famous and most misunderstood cousins.
Totally. Growing up, the word Neanderthal was an insult, right? It meant you were a stupid, brutish knuckle dragger.
A caveman.
But the guide and modern science paints a very, very different picture.
A much more sympathetic one.
Absolutely. The Neanderthals were the original Europeans and West Asians. They evolved there in a harsh, frozen ice age world. Their bodies were adapted for the cold. They were shorter and much stockier than us, which conserves heat. They were incredibly strong. Their bones are much thicker than ours, like power lifters.
And they had those huge noses.
Yes, a big projecting nose to warm and moisten the freezing dry air before it hit their delicate lungs. And their brains. Their brains were, on average, slightly larger than ours are today.
So they definitely weren't stupid.
Not at all. And they weren't just brutes. They had culture. They had a rich inner life. The source highlights the evidence from places like the Shanidar Cave in Iraq. They found Neanderthal skeletons that had been deliberately buried.
Which implies ritual. It implies more than just dumping a body.
It implies they cared about their dead. Maybe they believed in an afterlife. Maybe they were just grieving. We don't know. But even more touching, they found skeletons of individuals who had suffered severe, debilitating injuries and then lived for years afterward.
Like what kind of injuries?
One older man had a withered arm that was probably useless from childhood. He was partially blind and deaf. In the brutal world of the Ice Age, if you can't hunt or defend yourself, you die. The fact that this individual lived to an old age means only one thing.
Someone was taking care of him.
Someone fed him. Someone protected him. They had compassion. They had a society that valued its members beyond their mere physical utility.
So what happened to them? They were so well adapted, they dominated Europe for hundreds of thousands of years. And then they just vanished about 30,000 years ago.
It is the million-dollar mystery of human evolution. There are a few competing theories. The first one is grim.
Violence.
The theory is that we Homo sapiens arrived from Africa with better technology and social organization, and we simply wiped them out. The first human-on-human genocide.
It's plausible. We know our species is capable of that.
Very plausible. Another theory is simple resource competition. Maybe we were just slightly more efficient hunters and gatherers, and over thousands of years, we just slowly starved them out. Or maybe it was climate. The climate was incredibly unstable back then, and maybe they just couldn't adapt to the rapid changes as well as we could.
But there's a fourth theory. The love, not war theory.
Interbreeding. And this isn't just this theory anymore. We have the receipts. We have the DNA evidence.
Right. We've sequenced the Neanderthal genome.
We have. And it turns out that most modern humans of non-African descent today carry somewhere between 1% and 4% Neanderthal DNA.
So they didn't really go extinct.
In a way, no. They were absorbed. They merged with us. They live on the inside of us. We are all, to some extent, hybrids.
That brings us to the moment where we became us, the great leap forward. Something happened around 40 or 50,000 years ago. Something just clicked.
The cognitive revolution. Physically, a human from 40,000 years ago looked exactly like you and me. You could give one a shave and a suit, put them on the subway, and no one would blink an eye. But mentally, the software got a massive upgrade.
This is when we see the explosion of art.
And not just, crude scribbles. We're talking about the cave paintings at Lascaux in France and Chauvet. These are masterpieces. They show perspective, they show motion, they use the contours of the cave wall to create a 3D effect. These aren't just pictures of animals.
They're stories.
They suggest that humans were now capable of abstract thought, of symbolism, of creating and sharing a mythology.
And vanity makes its first appearance.
Yes, vanity. We start finding jewelry. Perforated shells, beads made of mammoth ivory, adornment.
Which seems kind of trivial, but it's actually huge, isn't it? It implies a sense of individual identity and social status. I am wearing this special necklace, so I am important.
Exactly. It signals a new level of social complexity. And don't forget, one of the most important inventions from this period, the sewing needle.
The most underrated tool in human history.
It's gotta be up there. A simple sliver of bone with a hole in it. But it meant you could create tailored clothing. You could sew layers of animal hides together. That's what allows you to survive in the Arctic. It's what allowed us to conquer every corner of the cold, frozen planet. This explosion of creativity is what really finally separated us from the rest of the animal kingdom.
So we have art, we have tools, we have religion, we have clothes. But we were still living the same way we always had. We were nomads, hunter-gatherers. Then, around 10,000 BC, everything changes again. The Neolithic Revolution.
The invention of farming. The single biggest change in the human story.
Why did we stop wandering? I mean, we'd been doing it successfully for millions of years. It seemed to be working out pretty well for us.
The climate changed, the last ice age ended, the world got warmer, wetter, and much more stable. For the very first time, planting a seed in the ground and having a reasonable expectation that it would grow and you could harvest it was a viable life strategy.
And once you start farming, you can't really go back.
It's a trap, in a way. A wonderful, productive trap. Farming gives you something you never had before. A food surplus. You can grow more wheat than you can eat today. That surplus leads directly to a population boom. You can support more children.
But now you have more mouths to feed, so you have to farm even more land.
Exactly. You can't just pack up and go back to hunting. You are locked in. You're tied to the land.
And the source points out a really interesting counterintuitive downside here. We tend to think of the rise of civilization as a story of progress, of things getting better. But early farmers were actually much unhealthier than the hunter-gatherers they replaced.
Oh, much unhealthier. The skeletal evidence is clear. They were shorter. They had terrible teeth from all the sugary, starchy grains. They had arthritis from the back-breaking repetitive labor of grinding corn and tilling fields.
And they got sick more often.
Yes. Living in crowded, permanent villages with your domesticated animals. That was a recipe for disaster. Diseases like smallpox, flu, and measles made the jump from livestock to humans. Hunter-gatherers lived in small, mobile groups. Plagues couldn't really take hold. In a village, they could wipe everyone out.
So we got shorter, sicker, and we worked harder. Why on earth did we stick with it?
Because of that surplus. The surplus allowed for one crucial thing: specialization. If one farmer can grow enough food to feed 10 people, the other 9 don't have to be farmers anymore.
They can be potters.
Or soldiers, or priests, or kings. This is the birth of social hierarchy, the birth of the haves and the have-nots.
And the birth of the city, Jericho, Cataluyuk in Turkey.
And when you start putting thousands of strangers together in a city, you need new ways to manage them. You can't rely on family bonds and peer pressure anymore. You need formal laws, you need administration, you need bureaucracy.
You need to start writing things down.
Writing is the final game changer. It starts in Mesopotamia as something really boring. It's just accounting. Farmer Bob owes the temple 5 bushels of barley.
The first spreadsheets.
Basically, yes. But it quickly evolves into recording laws, and then history, and then poetry. And the source made a brilliant point about this. Writing allowed us to store our collective knowledge outside of our own brains for the first time, precisely. Before writing, if the wise elder of the tribe died, the library burned down. All that knowledge was gone. With writing, knowledge becomes permanent. It becomes cumulative. We can build on the discoveries of people who have been dead for centuries. We stop reinventing the wheel every generation, and we start building rockets.
Which brings us to the march of history, as the book calls it. Let's fast forward a bit. We see the rise of the classical world: Greece, Rome, the Han Dynasty in China. What's the big theme there?
Organization at a massive scale. These are the first true superpowers. The Greeks gave us the software of political society ideas like democracy, philosophy, the concept that you aren't just a subject, you're a citizen with rights and responsibilities.
And the Romans gave us the hardware.
The hardware. The engineering, the aqueducts, the roads that tied a vast empire together, the system of law. And at the same time, the Han Dynasty in China was developing the civil service, this idea of managing a massive empire, not just with brute force, but with a trained, educated bureaucracy.
Then Rome falls, at least in the West. We get the Dark Ages in Europe. But the source is quick to remind us the lights did not go out everywhere.
Not at all, not even close. While Europe was stagnating, the Islamic Golden Age was flourishing. They were preserving all that Greek math and astronomy and building on it. They gave us algebra, advances in medicine, optics. At the same time, China was having its own golden ages under the Tang and Song dynasties. And connecting them all was the Silk Road.
And the Mongols.
The Mongols. They're a fascinating case. Unbelievably brutal conquerors, yes. But by creating the largest land empire in history, they created a period of stability called the Pax Mongolica. You could, in theory, walk from Poland to Beijing with a gold plate on your head and not get robbed. They brutally reconnected the world.
Then comes the next great catalyst, Technology. The book focuses on two in particular, gunpowder and the printing press.
Gunpowder, invented in China for fireworks, was weaponized in Europe, and it completely upended the old social order. It ended the age of the armored knight. You no longer needed a lifetime of training and immense wealth to be a powerful warrior. Any peasant with a gun could kill a nobleman. It democratized violence.
And the printing press democratized knowledge.
Gutenberg's invention is arguably the most important in the last 1,000 years. Suddenly, books weren't rare, hand-copied luxury items for the elite. Ideas could be mass-produced and spread like a virus. You don't get the Protestant Reformation or the Scientific Revolution or the Enlightenment without the printing press. It broke the churches and the state's monopoly on information.
Which leads directly to the modern era, the Industrial Revolution, steam power, factories.
This was the biggest lifestyle shift since the invention of farming. For 10,000 years, the rhythm of most human lives was dictated by the sun and the seasons. You woke up, you worked the land. Suddenly, millions of people are moving to crowded cities, living in slums, and working by the clock in a factory, surrounded by loud, dangerous machines.
And then, the 20th century? The source has a great name for it. The century of extremes.
It was a paradox on steroids, an absolute whirlwind. On one hand, you have unprecedented progress. Penicillin, airplanes, computers, the internet. We doubled our average life expectancy in 100 years.
And on the other hand?
On the other hand, you have the industrial-scale slaughter of the trenches in World War I, the Holocaust, the gulags, the atomic bomb. Unprecedented destruction.
It's that dual nature of humanity again, isn't it? We can cure polio, and we can vaporize a city.
And now here we are in the era of globalization, the global village. You can eat a Big Mac in Moscow, watch a Korean movie in Ohio. We are more connected, for better and for worse, than we have ever been.
Which brings us to the final section of the book, the future. Where are we going from here?
The scary thing, the thing that's hard to wrap your head around, is the speed, the acceleration of change.
The source had a great statistic on that.
Yeah, it took our ancestors something like 100,000 years to upgrade from stone axes to copper axes. But it took us only 66 years to go from the Wright brothers' first flight to Neil Armstrong walking on the moon.
That is just dizzying. And biologically, we are struggling to keep up with the world we've created.
And that's the core of the mismatch theory.
Explain that.
Our bodies and our brains were sculpted by millions of years of evolution to survive on the African savanna. We are built to be on the move all day, to experience periods of feast and famine, to crave sugar and fat, because in that environment they were rare, life-saving sources of energy.
And now?
Now we sit in chairs for 8 hours a day staring at glowing screens, and we live in a world with unlimited access to donuts and soda. We are essentially cavemen living in a sci-fi movie. Our software is ancient.
And that mismatch is the root of so many modern problems. The obesity epidemic, diabetes, the back pain we talked about, the anxiety.
Exactly. Our environment has changed far, far faster than our biology can adapt. We are physically and mentally out of sync with our own world.
And at the same time, we're straining the planet itself. Overpopulation, climate change, resource depletion.
We are hitting the physical limits of what this one planet can support. But in another paradox, at the very same moment, we are unlocking the code of life itself. Genetic engineering. CRISPR technology.
We are on the verge of being able to play God.
We are. We have the potential to start directing our own evolution, to edit out genetic diseases, to potentially enhance things like intelligence or longevity, but the ethical questions are staggering and terrifying. Who gets to decide what is a disease versus a trait? Who gets access to this technology?
The source wraps up with this really powerful, sobering thought from the editor, Robert Winston. It's about fragility.
He makes the point that despite all our technology, our skyscrapers, and our internet, we are still those same fragile, naked apes from the savannah. Our technology has changed, but our fundamental nature hasn't. We are still capable of immense love and cooperation, but we are also still tribal, fearful, and capable of immense aggression.
He says we have the power to either self-destruct through nuclear war or environmental collapse, or to solve our greatest problems. It's a choice.
It is the ultimate test, isn't it? We have spent our entire existence taming the wild, taming the planet, and now the final frontier is learning how to tame ourselves.
That really is the challenge. So looking back at this entire journey, from a single cell to a fish crawling out of the water, to a bipedal ape, to a painter in a cave, to an astronaut standing on the moon, It's just a lot to take in.
It is an absolutely incredible story. And if there's one single theme that runs through it all, it's that we are the ultimate generalists. We aren't the strongest species. We aren't the fastest. We don't have sharp claws or thick fur or venom.
But we're adaptable.
Incredibly adaptable. We are curious. And most importantly, we are profoundly social.
Our real superpower is cooperation.
It's sharing knowledge. That's how we survived and thrived. We are the species that learns from its elders and teaches its young.
So here's the thought I want to leave everyone with to bring it full circle. We started this whole deep dive with the mirror test. We are the only species that truly recognizes itself in the reflection. We know that we are, but the real question is, do we really know who we are?
That is the question, isn't it? We have spent 6 million years evolving to survive a world that, for the most part, no longer exists. We've built this new artificial world, but we're still running on the old software.
And we've created tools, artificial intelligence, nuclear power, genetic editing, that might be evolving faster than our own wisdom is. Are we actually ready for the next great leap forward?
Only time will tell. But looking at our track record of improbable survival and adaptation, I wouldn't bet against us.
Let's hope you're right. That's all we have for today's deep dive. We hope this gave you a new and maybe a deeper perspective on the person you see in the mirror every morning.
It certainly makes you think about that reflection a little differently.
Thanks for listening. Stay curious.